In this series of expansion of functions, we will see how to find expansion of log 1 plus x. Now let fx equals log 1 plus x. So f dash x will be 1 upon 1 plus x. So f0 will be log 1 plus 0, log 1, which is 0. Here f dash of 0 will be 1 upon 1 plus 0, that will be 1. Next, f double dash 0 will be minus 1 upon 1 plus x whole square. This is because derivative of 1 upon x is minus 1 upon x square, and f double dash 0 will be minus 1 upon 1 plus 0 whole square, that will be minus 1. This f double dash x can be written as minus 1 plus x raised to minus 2. So therefore f triple dash x will be minus of minus 2 1 plus x raised to minus 2 minus 1, that will be 2 upon 1 plus x cube. That can be written as, on the lines of f dash x, f double dash x, this will be 2 into 1 upon 1 plus x whole cube, and f triple dash of 0 will be 2 upon 1 plus 0 whole cube, that will be 2, or 2 factorial. Now this f triple dash x from this can be written as 2 into 1 plus x raised to minus 3, and hence f fourth dash x, that is fourth derivative, will be minus 6 1 plus x raised to minus 3 minus 1 minus 4, that will be this minus, we write this 6 as 3 into 2 into 1 upon 1 plus x raised to 4, and the fourth derivative of 0 will be minus 6 upon 1 plus 0 raised to 4 minus 6, that we write minus 3 factorial. On the same lines, f5 dash x will be 4 into 3 into 2 into 1 upon 1 plus x raised to 5. Therefore f5 dash of 0 will be 24 upon 1 plus 0 raised to 5, that is 24, or 4 factorial. Now for fx equals log 1 plus x, we have f0 equals 0, f dash 0 equals 1, f double dash 0 equals minus 1, f triple dash 0 equals 2 factorial. Fourth derivative at x equals 0, minus 3 factorial from here, and fifth derivative at x equals 0, 4 factorial. Now we will substitute these values in the Maclaurin's series and find the expansion of log 1 plus x. By Maclaurin series we have fx, that is log 1 plus x, equals f0 plus x f dash 0 plus x square upon 2 factorial f double dash 0 plus x cube upon 3 factorial f triple dash 0 plus x raised to 4 upon 4 factorial f fourth derivative at x equals 0 plus so and so forth. That will be log 1 plus x equals f0, which is 0, plus x into f dash 0 is 1, plus x square upon 2 factorial into f double dash 0, which is minus 1, plus x cube upon 3 factorial into f triple dash 0, which is 2 factorial, plus x raised to 4 upon 4 factorial into fourth derivative at x equals 0, which is minus 3 factorial, plus x raised to 5 upon 5 factorial into fifth derivative at x equals 0, which is 4 factorial, plus so and so forth. That will be log 1 plus x equals this x minus this x square upon 2 plus this x cube upon 3, because 2 factorial of 3 factorial will cancel with this 2 factorial, minus x raised to 4 upon 4, because 3 factorial of this 4 factorial will cancel with this 3 factorial, plus x raised to 5 upon 5, because 4 factorial of 5 factorial will cancel with this 4 factorial minus so and so forth up to infinity. So this is the expansion of log 1 plus x by using Maclaurin's series. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Next we see expansion of log 1 minus x. So let fx equals log 1 minus x. We have found expansion of log 1 plus x, which is x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4 plus x raised to 5 upon 5 minus so and so forth up to infinity. Expansion of log 1 minus x can be obtained by replacing x of this expansion by minus x. Therefore, log 1 minus x will be minus x minus minus x square upon 2 plus minus x cube upon 3 minus minus x raised to 4 upon 4 plus minus x raised to 5 upon 5 plus so and so forth up to infinity. That will be log 1 minus x equals minus x square upon 2 minus x cube upon 3 minus x raised to 4 upon 4 minus x raised to 5 upon 5 minus so and so forth up to infinity. So this is the expansion of log 1 minus x we can obtain by replacing x by minus x in the expansion of log 1 plus x. We have tan h inverse x, that is hyperbolic tan x is half log 1 plus x upon 1 minus x. We will find expansion of hyperbolic tan inverse x by using expansions of log 1 plus x and log 1 minus x. But before that, let us see why tan h inverse x is half log 1 plus x upon 1 minus x. For that, let us assume tan h inverse x equals y, so that x becomes hyperbolic tan y, which is hyperbolic sin y upon hyperbolic cos y. Now hyperbolic sin y is e raised to y minus e raised to minus y upon 2 upon e raised to y plus e raised to minus y upon 2. So 1 upon x will be, after cancelling this 2, e raised to y plus e raised to minus y upon e raised to y minus e raised to minus y. Here we will apply componendo dividendo, which is property of two equal ratios. Accordingly, this will be 1 plus x upon 1 minus x equals e raised to y plus e raised to minus y plus e raised to y minus e raised to minus y upon e raised to y plus e raised to minus y minus e raised to y plus e raised to minus y. E raised to y minus e raised to y will be 0. E raised to y minus e raised to y is 0. So it will be 2 e raised to y upon 2 e raised to minus y, which is 1 plus x upon 1 minus x equals, cancelling this 2, e raised to 2y. Converting this exponential form into logarithmic form, this will be 2y equals log 1 plus x upon 1 minus x base e, or this will be y equals half log 1 plus x upon 1 minus x, which is what we have written here. We have tan h inverse x equals half log 1 plus x upon 1 minus x, which is half log 1 plus x minus log 1 minus x, according to the laws of logarithm, which equals half into expansion of log 1 plus x is x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4 plus so and so forth minus expansion of log 1 minus x minus x square upon 2 minus x cube upon 3 minus x raised to 4 upon 4 minus so on and so forth, which equals half x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4 plus so on and so forth plus x plus x square upon 2 plus x cube upon 3 plus x raised to 4 upon 4 plus so on and so forth. This will be half into minus x square upon 2 plus x square upon 2 is 0 minus x raised to 4 upon 4 plus x raised to 4 upon 4 is 0, so on and so forth. So x plus x will be 2x, x cube upon 3 plus x cube upon 3 plus 2 times x cube upon 3 plus 2 times x raised to 5 upon 5 plus so on and so forth, which is half into taking 2 common from each term, x plus x cube upon 3 plus x raised to 5 upon 5 plus so on and so forth up to infinity. Cancelling these two, we get expansion of hyperbolic tan inverse x equals x plus x cube upon 3 plus x raised to 5 upon 5 plus so on and so forth up to infinity. So this is the expansion of hyperbolic tan inverse x. Next we will study expansion of 1 plus x raised to m, and from this expansion we will deduce two important results. 1 plus x raised to minus 1 equals 1 minus x plus x square minus x cube plus x raised to 4 minus x raised to 5 plus so on and so forth up to infinity. And number 2, 1 minus x raised to minus 1 equals 1 plus x square plus x cube plus x raised to 4 plus x raised to 5 plus so on and so forth up to infinity. So for the expansion of 1 plus x raised to m, we assume fx equals 1 plus x raised to m. So f of 0 will be 1 plus 0 raised to m, that is 1. f dash x is m into 1 plus x raised to m minus 1. Therefore f of 0 will be m into 1, that is m. F double dash x will be m into m minus 1 into 1 plus x raised to m minus 2 gives f double dash 0 equals this m into m minus 1 into 1. F triple dash x will be m into m minus 1 into m minus 2 into 1 plus x raised to 1 minus 3, that gives f triple dash 0 equals m into m minus 1 into m minus 2. Now we have f0 equals 1, f dash 0 equals m, f double dash 0 equals m into m minus 1, f triple dash 0 equals m into m minus 1 into m minus 2, etc. Now we will use Maclaurin's series to find the expansion of 1 plus x raised to m. Maclaurin's series is fx equals f0 plus x f dash 0 plus x square upon 2 factorial f double dash 0 plus x cube upon 3 factorial f triple dash 0 plus so on and so forth up to infinity. At this stage, let us assume mod x less than 1. 1 plus x raised to m will be 1 plus x into m plus x square upon 2 factorial into m into m minus 1 plus x cube upon 3 factorial into m into m minus 1 into m minus 2 plus so on and so forth up to infinity. That will be 1 plus mx plus m into m minus 1 upon 2 factorial x square plus m into m minus 1 into m minus 2 upon 3 factorial x cube plus so on and so forth up to infinity. Obviously, if m is positive integer, then we get finite number of terms on right hand side. In this expansion of 1 plus x raised to m, we will study two possibilities. First, what if m is minus 1? Then we will get 1 plus x raised to minus 1 equals 1 plus minus 1x plus minus 1 into minus 1 upon 2 factorial x square plus minus 1 minus 1 minus 1 minus 1 minus 2 upon 3 factorial x cube plus so on and so forth up to infinity. This will be 1 minus x plus 2 upon 2 factorial will be 1, so it is x square minus into 1 into 2 into 3, which is 3 factorial, that cancels with this 3 factorial and gives us minus x cube plus so on and so forth. So the first important result that we get is 1 plus x power minus 1 is 1 minus x plus x square minus x cube plus so on and so forth up to infinity. Secondly, we will make a small change by replacing x by minus x in this expansion. So that gives 1 minus x to the power minus 1 equals 1 minus x plus minus x square minus x cube plus so on and so forth up to infinity. So that will be 1 plus x square plus x cube plus so on and so forth up to infinity. So we get another result 1 minus x raised to minus 1 as 1 plus x square plus x cube plus so on and so forth up to infinity. So we get these two important results from the expansion of 1 plus x raised to m. If you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.